Hello, this is Jakub Staron here on MedChem Essentials scientific seminars. Today we continue talking about permeability, but this time we'll focus on issues with permeability assays. We'll begin the presentation with some recap on membrane construction, then we'll recap on some influencing factors that influence permeability, then we'll see what factors actually can screw up our permeability assay. We will discuss some common issues and we'll see how we can deal with those issues. As we spoke some time ago, membrane is a fluid-like bilayer arrangement of phospholipids. It is composed of outer layer of electrically neutral lipids and inner layer of negatively charged lipids. This is quite important. Other factors that affect permeability is lipophilicity and size, which we discussed a week ago. So, let's see permeability dependence. Some time ago, when we were discussing permeability assays, we mentioned that the recovery can be lower than 100%. So actually, if recovery level is less than 65%, then we cannot rely on the readout of such an assay. This lower recovery can be contributed to different reasons. So one is binding of a drug to plastic walls or filters. Another one is concentration of a compound in cellular compartments. And the third one, because of metabolism of compounds by these metabolizing enzymes found within cells. How to deal with binding of a drug to plastic walls or filters? This is very abundant for highly lipophilic drugs. So, in order to improve permeability of a compound, let's say we increased lipophilicity of our drug, but we don't see increase of permeability. It's fairly constant, but we see drop of recovery. That may be a highlight of a compound being bound to plastic. So it was reported that several labs shown that inclusion of bovine serum albumin BSA to the reservoir, it increased permeability of lipophilic test compounds. This provided a more physiological sink conditions because the BSA in the receiver compartment, it somehow trapped, it sinks, it traps the lipophilic compound and supports the permeability. Bovine serum albumin here reduces the accumulation of hydrophobic compounds in the cell membrane, improves solubility of these compounds, reduces non-specific binding to filters and plastics. There are, however, some drawbacks of using BSA in the assay. The preparation of sample of LCMS sample can be more tedious. Also, secretory transport from basolateral to apical may be decreased because of these highly protein-bound compounds. So we added this BSA to basolateral site. This increased the readout, increased recovery by influx, but the efflux is decreased because the compound got trapped in the receiver well. Other factors that affect permeability are charge. So basic compounds can show lower permeability not because they are poorly permeable, but because they are bound to certain cellular compartments because of their basicity. Let's look what is the mechanism of this. This is the visual representation of a cell. So we have, in the cytosol, we have pH of around 7.2. There is an equilibrium between the drug being anionized and ionized. But there are cellular organelles with acidic pH of 5, and these are lysosomes. So, as we discussed last time, the unionized form of the amide can cross the lipophilic membrane, but inside the lysosome it will be protonated, and thus it will be ionized and it will be trapped. So this lipophilic membrane amide permeates the membrane and it gets trapped inside because of protonation. However, the acidic pH of lysosomes is regulated by a proton pump here. It pumps protons inside, and through this mechanism, lysosomes they obtain the acidic nature of the environment inside them. And we have a compound, bacillomycin. If we will inhibit this proton pump, then we will increase pH in lysosomes, and those compounds will no longer be trapped inside. This is the actual example from an experiment, that series of test compounds that were expressing very, very poor recovery to such extent that it was impossible to actually measure the permeability without bacillomycin. With addition of bacillomycin, we see a marked increase of recovery, and some redoubt and permeability could actually be measured. On average, addition of bacillomycin here increased recovery by 26%. This lysosomal trapping, it causes a drop of approximately 2.2 centimeters per second per 10% decline in the recovery. This is not the only way we can increase and deal with this issue, increase recovery. Another one is that we can buffer the whole environment by addition of ammonium chloride. So if we add ammonium chloride to all compartments to have pH of 7.4, this will improve recovery as well. So a standard assay, recovery A to B, fairly poor. With ammonium chloride, we also have complete recovery. So the permeability assay could be performed. However, there are certain drawbacks of using ammonium chloride as an additive to permeability assay. This misinterprets the physiological conditions, which is one side showing 6.5 pH, another one side showing 7.4 pH. So by addition of ammonium chloride, we equalize pH across both compartments. System with or without bovine serum albumin, it also is closely reflects the actual solubility assay. With this presentation, we finished this discussion about permeability. Now we will move on to solubility, which is the next crucial factor influencing bioavailability. Thank you very much for your attention. See you next time. Bye-bye.